This is the first data center tour I've ever done where I cared about the weather. In fact, when we were planning on coming out here to Washington, D.C. to see this DUG Nomad setup behind me, it never occurred to me that if it wasn't 52 and sunny that we might have a bad go about it. But the weather does highlight an important component of this data center to go, and that's that it is rugged, it can be deployed anywhere in the world, hot or cold, and you can get 26 rack U of compute, storage, GPUs, whatever you want in this thing, and deliver a true AI or HPC story at the edge. So DUG is the creator of this thing, and DUG stands for Down Under Geo. They're a software company that does all sorts of analysis on seismic data. So they were pushing their software to the extreme, and as many creative software companies do, as they grew and expanded their business, they needed better and bigger hardware to do all the analysis. That's compute, storage, GPUs, accelerators, all that sort of thing. But what they found is to maximize their ability to run their applications with those hardware tools in tow, that they couldn't get the reliability, the serviceability, and the performance they wanted. Enter in a container kind of like this. In their Houston, Texas data center, they've got over 400 of these setups that are kind of similar to this, making them probably the largest immersion data center in the world. So the Nomad over my shoulder is just a smaller version of this. This is the 10-foot setup. It comes in 20 and 40 foot as well. And this, like I said, can be deployed anywhere. If you see the top, it's got hooks on it. You can take helicopter, pick this thing up and move it. Really what this is about getting all that compute power to where the data is being created. And yeah, the orange does stand out a little bit. This is the marketing version of this 10-foot container. Of course, in a more rustic environment that requires a little more secrecy, perhaps orange is not the way it would be deployed. We're going to tear this 10-foot container open and show you all the stuff inside. In fact, the first time I saw it, I assumed that was the data center bit. I was quite incorrect. Over here is where we've got the immersion tank and the servers. That's all for cooling, and we'll talk about the cooling and power delivery that's pretty neat in this system too. But like I said, in here we've got an immersion tank with 26 usable rack U of space. We've got servers from Hypertec. These are servers that are designed explicitly for liquid cooling in immersion tanks. We're going to talk with Solidigm about storage and that impact of data on edge AI and edge HPC use cases. They just showed at GTC a liquid-cooled SSD design that they're working on, and we're already dunking them in Castrol liquid fluid. Liquid fluid, that's kind of... So enough of me highlighting why we think this is so cool. Let's open up the doors and show you why it is so cool inside. So we've cracked open the doors, pulled the lid off, we've got a server out, and we're taking a look at the components inside. And Patrick, with Hypertec, these are your babies, your Trident servers.
Yes, they are, matter of fact, and thank you for having us here to talk about this product.
So you guys make servers dedicated to immersion cooling, which is a lot different than we think about immersion typically. Most of the other tanks I've seen have servers in them that are just repurposed air-cooled servers. What's the difference from Hypertec's
That's
perspective?
What the rest of the industry call immersion ready.
Immersion ready.
Yeah,
okay.
You take an air-cooled server, you make a couple of arrangements, and you go in a tank. What we did almost 5 years ago now is to think there is a real market for immersion. Immersion-born, that means you design from the ground up a server is fundamentally different than an immersion-ready,
right,
where you take what exists and you try to make the best of it.
Now we've seen that in the immersion-ready case, where they'll pull out some of the components, pull out the fans, and kind of plunk it in there, and off it goes. It's not quite as elegant, though, as what we're seeing with your designs, right?
As we thought about the immersion, depending on the component, on the GPU side, on the power supply side, on the CPU side, there is placement on the motherboard, right? We don't have it here, but on the GPU server, all the GPU are at the bottom of the tank,
right,
because it's where is the coldest temperature. But like you mentioned, on the power supply side, on the label side, for example, people don't talk about that. Because it's an immersion-born,
right,
we design like that. Everything has been thought about to be the most efficient, right? Because it's all about efficiency and vanity-free. As you can see, the machine is fairly open. There is nothing unnecessary.
Right. Well, and you need that for the fluid to be able to move through the system. The labels is actually hilarious to me, because somewhere along the way, somebody dunked a system in there and then came back a few days later and realized all the stickers, all the drive labels, all the things would
at the bottom of the
sink to
tank.
the bottom.
Yes.
Which is not great for maintaining your oil, right?
Oh, it's not great. The first thing is they have to pull out every single server out of the tank, remove the liquid, clean up everything, and restart all over again. So
right. So you learn that lesson once, probably, and then find an innovative way to cover the labels, in this case with another material.
Yes, we have two ways to do so. Again, because it's immersion-born, we know about all this problem. And we have, like the little label that you can see here, they are coated with an acrylic. You can think like a nail polish type of product, right? And in certain cases, we use labels who are manufactured to reside in oil. Don't forget, we are not the first one who use this type of liquid.
Right.
The oil and gas industry, they use that for 100 years. So we piggyback on some of what they did.
So Hypertec has a nail technician to make sure the labels are applied.
A nail polish technician? Yes, kind of. Yes, absolutely.
The only server company to have a nail technician.
Yeah.
So in addition to the storage server in one of these tanks, you'll typically have a bunch of compute servers as well.
Yeah.
I know you've got
I can pull one for you.
You've got 4 or 5 in here.
Hopla, one hand, right?
So
Hopla.
So we don't need the hoist for the single node. Oh man, look at that. So
dual socket. This case is dual socket Intel.
Okay, and so you pulled it out sort of carefree, and I think we've lost some of our oil.
Yeah.
But if you were doing this,
I will clean up. I promise.
If you were doing this for real,
you would stay above the tank.
You would stay above the tank.
Yeah. Is you have some kind of crossbar who go, and you pull out and you put the node like that, so it continue to drip above the tank.
Right. When it comes to the servers, you're designed for immersion, and that means you've made changes in the way we think about CPUs as well. The heat sinks, the materials, everything changes when it's in immersion.
We do immersion cooling at large for 5 years now. So we went through trial and tribulation, right? Okay. We learn along the way, like the sticker, like everyone, right?
Right.
And we saw in our testing that the viscosity of the liquid was becoming important because changing oil, for example, without mentioning who he was, we could gain 3 to 5 degrees C at the CPU temperature with changing the heatsink. So we started to develop custom heatsink per type of oil. That means if the customer say, you know what, I'm going to use Castrol, we have heatsink A, or I'm going to use the Shell, we have heatsink B, is to optimize the temperature and the efficiency.
That's pretty wild to think that the viscosity has that much impact on how you would design a heatsink, for instance.
Yeah.
And thermal paste is another thing, right? We talked about the glue on stickers goes away very quickly. What about traditional thermal paste?
So the thermal paste, even the immersion ready do the same because you can't do anything else, is you need to remove the thermal paste of the processor and change it by an indium foil, which is kind of a metallic type of foil, who doesn't disintegrate in a tank.
So a lot of these Nomad deployments will have GPUs as a key component. Tell me about some of the GPU servers that you guys have.
So we started with the A100, we went to the H100, 100 NVL. Now we are installing H200 NVL in our machine. We went from a 1U 19 inches with 3 GPU to a 2U 19 inches with 6 GPU.
Right.
And now we just brought something for the people who can use 21 inches, like we find in some tanks, a 1U 4 H200, right? The density in a 50U tank is 200 H200 in a tank. Think about today, anyone who do the DGX, they barely put 64 GPU in a rack.
Right.
200. So now we talk about a different world here in terms of density, and every data center today would like to be able to compress and to put as many components as possible in a smaller footprint.
Yeah, that's amazing. And I think when we consider how a customer would lay this out with GPUs, compute, and now with the storage too, these drives, and we'll talk with Solidigm about this a little bit, but the densities available to you from a system designer have got to be pretty impressive.
What's extremely interesting, in my opinion, with the Nomad tank, you compress an entire data center in one tank,
this, yeah.
suddenly you end up to be CPU, GPU, and the last component was the storage.
So when we look at the container here, it's really a rack kind of tipped over on its side, but you see the PDUs that would just be in a normal data center, the power runs, it feels kind of similar. So the fluid is the first obvious difference, but the second one, and I'm a little short, so I have to step up here to see, but the manifolds here in this piping, this runs to a chiller in the back side of the unit. And talk about the thermals, because I think that's another one of the questions, especially when it's hot out, if it's only in the 50s out here in a parking lot today, but this can go literally anywhere in the world. So if I drop this off in a desert, you really just need this and power, right? A generator?
Yes, you're absolutely right. The system here is absolutely self-sufficient. You don't need to do anything. It will cool the same. It's always the delta between the in and the out.
Right.
If it's, let's say, 30 in, it could be 40 out. If it's 80 in, you will be 90 out, right? Do you see what I mean?
Right. But
as long as you monitor the delta,
right,
you can run at any temperature.
And the chiller that's in there now is, I mean, it's all not, it's off the shelf, right? It's
pretty much.
It's common equipment,
pretty much,
right?
Yes.
And the way Doug's architected this Nomad and this system makes it really simple to plunk it down. I think there's a great crane video of this one being put in the parking lot. It's really not that bad to move this around either if you really need it to be somewhere at the edge.
You're absolutely right. I can fill up the entire tank here, plugged to the switch,
right,
and you're up and running in 2 hours. So that's why I think the Nomad become extremely attractive for the edge, and I'm putting that on record. The edge is the future of AI. Data center will phase out. Today is all about hyper data center, right?
But so your vision is push more of this to the edge where the data is created.
Absolutely, because they're going to run out of space and power. But also, at one point, you need to get closer and closer to the edge to have the lowest latency.
Well, that would be something, and this certainly appears ready for the job. You talked about networking. Actually, when I was climbing on this before, I noticed the cutouts here, but that's what these are for. We don't need to liquid cool the switches.
You're absolutely right. Depending of the environment, if you are in a super hot environment, we will recommend to put the switch in the tank because of the temperature.
The ambient temperature, right. Which makes a lot of sense. We get a lot of questions about performance. We're just talking about networking. A lot of people get concerned about optical interference depending on the network they're using. Any sort of challenges for the drives to communicate on the backplane?
No.
You see anything like that at all?
Absolutely not. Today, I'm not saying when PCI Express 7 is here, right?
Right.
Whatever, when it is, we will have to reconsider that. But as of today, even with the fastest card or the network card, even 800 gig, you work fine. We use specific cable, right? You know, you talked about the label earlier.
Right.
All the cable you see in this machine, they are specifically designed to be in immersion.
And
it's not a regular cable.
That had to happen because in the early days, I heard a number of people complain about the wrapper around the kit cracking or being brittle.
If you use, for example, including the power cable, you see the power cable are very malleable. If you use a regular power cable, after a few weeks in a hot temperature, the cable harden and it becomes brittle. And if you try to bend it, it break the housing, right?
Right.
So what we learned very early on is every single cable we use here, every single one of them are PVC free, and they are specifically made to be in immersion. Now talk about the network cable. We use only immersion certified network cable. Okay. It could be regular DUG, AOC, you know, you talk about the fiber,
any provider,
DRG45, everything is specific to be in immersion.
And that's what changes the game for the cables then on the fabric side. So this is great. We talked about all the different servers, but one of the reasons that we're really excited about what's going on here is the density available of the SSDs inside to let you get a giant data footprint in this tank next to your GPUs at the edge. And that's really exciting. So let's talk a little bit more about the storage. So we've pulled out one of the servers. This is the storage server from Hypertec. When you've got a system like this at the edge where the data is being created and collected, and now with the GPUs, we can run analysis on it, whether it's AI or something else, having a nice big storage footprint makes a huge difference.
Yeah, I talk to a lot of customers who tell me, how much data they throw away just because they don't know how to use it at the edge, or they don't have a way to send it back to the cloud. But if you can take a beautiful container, because I love the color, and drop this out at the edge where you need to have your data analyzed, and then only take the compute that you've done and send that back to the cloud, you're filtering all of the data that's coming in before you have to ship all of it back. And so it saves money on both sides.
If you can run things at a high TDP but still cool them effectively, their lifespan is longer, and throughout the whole IT stack, heat is what kills, right?
That's right.
And so it's true with SSDs as well, same sort of thing.
Yeah, and the way it was explained to me is a pretty interesting way to think about things. If you can keep a nominal temperature throughout the life of a product that's running even at a higher TDP than it's meant to, by not cooling and heating and expanding and shrinking and popping, soldering, and all of those things,
right,
it's just much more stable. And I think it was a little birdie who told me they had something like this going for about 4 years with 0 failures.
0 total failures. No NICs, no CPUs, GPUs, drives, not a single component, which is why immersion's so exciting. And then from the Solidigm perspective, I mean, you go where your customers are, but the density of these things, so we've got 16 of them in this one use server. So with these little guys, you get pretty good density at 15 terabytes.
Yeah, this is about a total of 16 drives. So you're about 320 terabytes of data, 320 terabytes of data. If you were to swap this board out for the E1L,
yeah, a little longer,
probably stretch a little bit down to here, you're pretty close to 2 petabytes. You're at about 1.9 petabytes total in one server.
One U.
U.
And so in this tank, we've got 26 compute U available to us for servers. And from a storage perspective, you guys are able to drive tremendous density, which is the important part when every rack U in something like this makes a difference, because they want the rack U's for the GPUs, for the compute servers. And I think in the days before, they wouldn't even really considered putting a petabyte or 2 or 3 in a system like this because it just wasn't feasible. Fundamentally, it's just kind of wild to think about, this case being filled up with the oil, but in the server knows no difference. And we worry about serviceability because that's what the industry worries about. But if the parts never fail, then maybe we're worrying about the wrong things. And the other thing that I think people worry about is the footprint of these units. So obviously you wouldn't put this giant Nomad thing in a data center, but you can do immersion just like this in the data center with purpose-built tanks. And when you do that and tip it over, it takes up the space of maybe 3 racks in terms of total width and footprint. But the density that they get out of these things is pretty amazing with all these high power 1 and 2 U servers. And the longevity too. I mean, we've heard plenty of stories about guys that started with immersion 8, 9, 10 years ago, and all that equipment is still running. That's a wild thought. Now,
a wild thought.
It's not as many cores as whatever you would get today or the frequencies, but to get that longevity out of a single piece of equipment is nutty.
Yeah, and then if you think about where data centers are going with graphics engines, once you get past a couple 100,000 kilowatts per rack, and the amount of power that you need to cool that starts to exceed the amount of power that you're giving your actual computer in the rack, having this as an option is just a no-brainer.
So as the administrator of our data center of 8 racks in Cincinnati, this is entirely different for you. It
looks fantastic.
Well, it's
our
prettier than your data
wood,
center.
But this, it's nice. It's orange.
Nice and orange.
Yeah.
So aside from the tank, which I guess is the most noticeable change, the rest of it's pretty similar, right?
Well, yeah. I mean, you have your PDUs, you have your power supplies, you have your equipment.
Right.
That's kind of dangling. It's a little bit different from what a normal data center would be, but a lot of the same type of hardware, just kind of propped up onto a wall.
Well, the thing that's interesting too is the engineering that they've done to pull all the serviceability to the front or the top of the server, right?
Well, yeah, we've seen hyperscale servers where it might have power supplies and a lot of connectivity on one side and maybe not as much on the rear. This, it's really anything that has to go in and out of the system is from the top.
It's got to be, because there's no access under the bottom of this thing.
Yeah.
So that's different. It's on its side, which we talked about. It's obviously full of oil, which is a little bit different. But the way the thermals work, when you take the heat off of the GPUs, CPUs, the RAM, the storage, all of that, That goes to the oil, and then what do we do with the heat from there?
So they have 2 heat exchangers, and it's 26 U of space between the 2 heat exchangers, and it's a closed liquid loop to go from the oil over to a cooler on the other side of this platform.
Yeah, let's take a look at that, because that's kind of interesting the way this works. The data center portion of it itself is actually relatively small, and then back here, the bulk of the unit is dedicated to the cooling unit, and of course, you can't come around the side without noticing the large extension cord.
The very large, beefy extension cord.
Yeah, but crack this open, because inside here, we've got the carrier unit, and then the power management for the unit itself.
Water comes in from the data center side, gets transported through these pipes, and gets brought into this carrier liquid air heat exchanger.
Okay, and like this is all off the shelf. It's a big shelf, but nothing about this is terribly complicated or unique.
No, it's bolted to a large transport container, but it's effectively containerized, so it's easy to move and just kind of plunk down where you need it. For this liquid air heat exchanger, air is drawn in from the side, and it's pretty simple filter method. It has chicken wire, so it's going to keep the birds out.
And that leaf.
Yes, but nice slats to kind of keep out anything large, but it's not something that you're worried about dirt really blocking this entrance.
Then this is your hot air evac, right, out the side of this thing?
Yeah, and it's not, I mean, this thing is built where it doesn't really matter if it's in the middle of a jungle, if it's in the middle of a desert, and honestly, they're looking for a 10-degree Celsius separation between the incoming outgoing air, and what's nice is you're looking for a 10-degree separation based on what the components are able to operate in. So I think they're saying this can operate anywhere except maybe a volcano.
Literally anywhere except for a volcano, because that's the only thing that's hot enough where this unit couldn't cool the gear down.
Yeah, so when you look at where these things can be deployed, you could have them deployed in a desert. You could have them deployed in the middle of Antarctica. And honestly, it seems to be a little bit easier for them to deploy it in a hotter area than colder.
Yeah. Yeah, and it's interesting, and you talked about the need for keeping large objects out of the cooling portion of the Nomad. You notice there's rubber gaskets all the way around the door.
Yeah, it's fully, I wouldn't say waterproof, but it's definitely weatherproof.
It's weatherproof, and then normally there would be a lid on top here.
Yeah,
and
keep dust out, debris, things from falling in.
But there's no ventilation on this side because you don't need it either, right?
No. Yeah, this side's really just set up to be more hygienic, so it's to keep the oil more pure, and everything going in and out is just located on the other side.
Yeah, so fundamentally this Nomad is a drop-it-anywhere data center to go, especially for edge AI and HPC use cases. The way they've architected this thing and engineered it is really impressive.
Everything about this really screams you're not going to break it. And honestly, I mean, you might be able to bend parts here and there, but it's deployed in really any situation that would probably destroy other equipment.
So what's your number one takeaway from the day we've spent with the DUG guys and the server and storage on this particular Nomad unit?
It's interesting to see the density argument be made of how much more you can put in a smaller footprint with these things.
Yeah, and I think that's the key thing, is that if you think about an 8 GPU server, for instance, that takes up, what, 6U?
6U, yeah, the XE9680.
In a air-cooled scenario, if we can do that now in 2, in a liquid-cooled, I mean, that really speaks to the density. You might lose more vertical rack space by going horizontal, but you're also gaining all of that density with those Hypertec servers.
Oh yeah, but we've had, I mean, Jensen at GTC was talking about the main limiter of data centers right now is power. And if most of the power in the XE9680 was going towards fans, if it's not just the size of the server, it's also the amount of power it's using.
That's another good point. So obviously no fans, less power, which makes a big difference. My biggest takeaway is that the labels. It's got to be the labels, that when they don't engineer the servers for liquid cooling, and there's a bunch of labels on parts, that they will quickly fall off and sink to the bottom, and your thermal paste goes away within hours.
Yeah, they're very concerned about things, contaminants.
Right.
Although I haven't said, they did say it's safe to drink a little bit, but I don't know if I want to.
We're not going to test that.
Well, should I?
No, don't drink it. Are you crazy? It's probably, yeah, go ahead, drink it.
Okay, well, here, I'll take a sip.
Oh, gosh.
Yeah, oh, I didn't die immediately.
What's it taste like?
Mechanical.
New Jelly Belly flavor, mechanical.
It's not going to sell well, but yeah, it tastes mechanical.
Yeah, they can put it in one of those Bean Boozled flavors where one's really good and one's mechanical. So after a day with the DUG Nomad, I think we need one of these in our parking lot.
It would definitely fit. I mean,
It's 10 feet long.
a spot and a half? It'd probably terrify our neighbors.
A spot and a half, but you could put it in the parking lot, you can put it anywhere you want. This is an amazing bit of kit and easily the neatest data center we've seen in a very long time, and the first time I've ever had to worry about weather when doing a data center tour. We'll put links to all this stuff in the description, and you can check out more about DUG and Hypertec and Solidigm and everyone else involved in this. But if you're thinking about Edge AI, Edge HPC workloads, this is something to consider to get the most value out of your AI investment.